Hi, welcome to the video on Unit 1.2 Radioactive Decay. This practice is to follow the 1.2 notes, so if you don't have that, you want to get those taken. In Part 1, we discuss and review absolute and relative age and dating. Now remember, absolute dating or absolute age involves age given in numerical values or numbers. Whereas relative, we describe age using words like younger, older, youngest, oldest. And that involves comparing things. So we went through different statements and wrote down whether the statements were associated with absolute or relative age. Now in Part 2, we go into a deeper dive of absolute age, where we talk about radiometric dating, which is a technique that is used to determine the absolute ages of different things. And what happens in radiometric dating, you have a radioactive or unstable isotope, so it's a type of atom, and that isotope, because it's unstable, will decay over time. Now, the rate at which it decays is measured or determined by what's called the half-life. And it's given the symbol T with a half next to it. And the half-life is the time it takes for half of a radioactive isotope to decay. So what we have here are some tables, and we're going to interpret the data in these tables to determine the half-life of the different isotopes. In each of these tables, you're given time in your X column, that's your independent variable, and your amount in the Y column. All right, so let's take a look at the first example. When we're trying to determine the half-life from a data table, what we're going to do is we are going to start at our starting amount. And usually that's the initial amount. And I know that this is the initial amount because time is set to 0, so this will be my initial amount. So I'm going to start here at 1600. And what I want to do is I want to figure out what's half of 1600. So 1600 divided by 2, and that's going to give me 800. Now that's the amount that I'm looking for or aiming for, because that would be the amount I have after one half-life. All right, so let's see if I can find 800 in the table. Well, here it is. So now what I want to do is I want to figure out the time it takes to go from 1600 to 800. Again, this is the time of one half-life. All right, so remember I just had to divide by 2 to get that information. Now my time is over in my X column, so I'm going to look over here, and that corresponds to 5 seconds. So my half-life here is 5 seconds. Don't forget the units. So 5.0 seconds. All right, we're going to do the same thing with B. So for B, once again, I have my time and I have my amount. But this time my amount is given in percentage, but it's going to be the same sort of information. So I start with my initial amount. Again, I know it's the initial because time is 0. And I'm going to divide my initial amount, 100%, by 2 to determine half of that. And that will be 50. So I got to find 50 in the table. Now this time it's not right underneath it. It's all the way at the bottom here, okay? So sometimes there's extra data. All right. So I found where I have 50% of my amount of my radioactive isotope. And I'm going to go over to the X column to determine that time. And that is 4,000 years, okay? So to go from 100% to 50% took 4,000 years. That's one half-life. So my half-life here is 4,000 years. Okay. Now let's look at the last example. This one is a little bit trickier, okay? So this is the data for what's called C. Borgium, 261. Now notice that my starting amount here is 120 grams, but is that my initial amount? Take a look at my time. Notice my time is not set to 0, so this is not my initial amount. The data that I have here was collected after C. Borgium 261 began to decay. So I'm going to have to do a little bit something extra here. So I'm going to put a little star because my initial time is not set to 0. Okay, so let's go go ahead and figure out what I need to do extra, but how we start will be the same. So I'm going to take my starting amount, which is 120, and I'm going to divide it by 2, and that would be 60. So to go from 120 to 60 is here, so I divided it by 2. So this is 1 half-life, okay? Now what I need to do is, I can't say that the half-life is 0.4 seconds because I didn't start at 0 seconds. What I need to do now is I need to subtract the time from my starting amount to where I have my half-life to get the half-life. All right, so I'll say that again. I basically need to find the difference in time from my starting amount to my half-life to determine the value of the half-life, okay? So I'm going to do 0.4 minus 0.2. And that gives me 0.200 seconds. That's the half-life here, okay? So once again, if your initial amount is not in zero, it's not 0, okay, so your starting amount is not, the time is not set to 0, you're going to have to subtract the time of your starting amount and then the time that corresponds to where you have 1 half-life has passed, okay? All right, so that's how we do that. All right, now you have some problems to try on your own. Pause the video now, and when you press play again, we'll go over the answers. All right, so let's look at number D. For D, the half-life here is 80. And notice how it says times 10 to the 6 years? That's the same as saying 80 million years. So this half-life here is 80 million years. For my next one, my half-life here is 3.5 minutes. It's the time it took to go from 44 to 22 grams. So 3.5 minutes. All right, for my last one, once again, we have to be careful because my initial time is not set to 0. So in this case, for my half-life, to go from 408 to 204, that took me from 30 to 50 seconds. So I need to subtract these two times, 50 minus 30. That gives me, I'm sorry, not seconds, minutes. That gives me a half-life of 20 minutes. All right, so that's it for part 2. We're going to flip over onto the back, or the first half of part 2. We're going to flip over to the back and look at examples with extrapolating and interpreting. See you in the next video.